only have about 10 minutes left in class, so I want to make sure what I record for today is what we need here. We did go ahead at the beginning of class before the quiz, and we did talk about some of the issues with the univariate packet part 1. So make sure that if you are watching this video, you go back and look at the notes portion of that. Today we're going to, for the last 10 minutes of class, we are going to go ahead and look at the 2 and 3, or parts 2 and 3. We will not be able to get through all of it. So your job is going to be to finish this for homework, what we don't finish in class. In addition to, you were also given part 2 of the univariate data, which says investigation. Most of you picked that up yesterday or last class on your way out. If you remember, I said you can have it before Labor Day if you want it. This is here. I only have 4 copies. I know Jessica needs one. Did I give you one already? No. Okay, because you were not here last class. Anybody else? You were not here last class. Yes, you were. But you didn't pick one up? Okay, so I will put it on School Fusion, okay? So I have this 1 copy. Can you get it on School Fusion for me? Okay, that's all I have left, okay? So somebody took more than 1. Anyway, you need to complete part 2 of the investigation, okay? Byron, if you want to come with me to my office right after class, I'll print you one, okay? Anybody else not get one that wants one, just come to my office, I'll print you one. Okay, but you need to complete both of those. So whatever we don't finish today and the part 2 investigation, and then you have to bring something. Remember what else you have to bring? A paper bag to cover your book. Okay, I will text you that information as well using the Remind app, but I just want to make sure you remember. So 3 things you need to bring with you to class on Friday. Let's talk about this matching displays for just a minute, though, to kind of get you started so you know what it is I'm asking you to do, at least for part 2. Part 3 is a little different. You're just figuring out which histogram matches what box plot. That's all, okay? For part 2, you're given 6 histograms, so you can clearly look at their shapes. And then you're going to look down here at their mean, median, and standard deviation. What do you notice about the median for each of them? They're all the same. As a matter of fact, why don't we draw it in? Go ahead and find your 50 and draw in the median for each of these. Now I'm estimating because I'm doing it on a smartboard here. Hopefully your line is a little straighter and prettier than mine. We're going to draw that in because that's the middle, right? So we're going to put the middle in on each of these. So we really have to use the mean and the standard deviation to make some determinations about which variable, 1, 2, 3, 4, 5, and 6, matches with which histogram. So one of the questions on your quiz stated, which measure of center and spread are you going to use and why? What do I have to look at to decide that? When do I use the mean versus the median? Those are the 2 measures of center, by the way. Anna? When I have a symmetric data set, I use mean. When I use a skewed data set, I use median. I can compare the mean and the median. When the mean and the median are the same, what's true about the data set? It's symmetric. How many, if you look down here, how many do you see where the mean and the median are the same? 3 of them. So there should be 3 symmetric data sets up there. Are there? But look at their standard deviations. They're all different. So let's look at the symmetric data sets for a minute. Let's look at the one that has a very large standard deviation. That's variable 2. Symmetric because the mean and the median are the same, but the standard deviation's large, so something's awry. So somebody tell me, looking at the 6 graphs, which one is symmetric but has a larger standard deviation? Histogram D. I agree with you. Histogram D is symmetric. There are 2 peaks. The red line is right in the middle of those two peaks. Why is the standard deviation large? Because most of the data is away from the center. Very good. So therefore, if you're looking at symmetric data with the largest standard deviation, I think variable 2 goes here. So those are the kinds of questions you're going to be asking yourself. Now we're going to look at the other two symmetric data sets, and you're going to decide which one has a very small standard deviation. And you'll decide between variable 3 and variable 6. Remember, standard deviation is a measure of spread. The smaller the spread, the more closely knit the data is to the center. Okay? The bigger the spread, the more data is away from the center. Yes? Histogram F is symmetric. Most of the data is around the middle. So I agree. I think that's 6. Good. Okay? Doing okay so far? What would the last, we're missing 3, right? So which one is the other symmetric data set? A, so I would think this would be 3. How do you feel? Okay so far? So now you have to look at the other ones. You have to look at 1, 4, and 5. We have 1 skewed left situation and 2 skewed right situations. When is the data skewed left? What happens with the mean? Is it smaller or larger than the median if it's skewed left? Smaller. Remember, the mean gets pulled in the tail, correct? So if it's smaller, wouldn't it be more left than the others? So which one of your answers here has a mean that is smaller? So this is variable 5. You with me so far? So I want you to make one last determination between variables, I believe it's 1 and 4, correct? And decide which one would you give 1 and which one would you give 4. They're pretty close. They're both skewed right. The mean is going to be bigger in both of them, and they are in 1 and 4. Wouldn't you agree? If you look at 1 and 4, the mean is bigger in both cases. Okay? But look at their standard deviations. One has a much larger standard deviation than the other, which means if you look at the 2 remaining graphs, which one is more spread out? I think histogram B is more spread out. It has a larger standard deviation. So I agree, Zach. I think that's histogram 4. And then, is it 4 that has a larger one? Yes. And then 1 would be this one. We had to reason through that, didn't we? We had to talk about it, make some determinations, look at shape, look at comparing the mean and the median, and then using that standard deviation. So you need to finish the matching display variables 3, which is just looking at box plots and histograms and trying to match up the ones that work. Okay? You also need to work on part 2. Part 2 is finished. It's honestly just using your calculator and adding it's not hard. It's just it's not a long thing. Nothing real difficult. So I want it finished by next time. Okay?